In this video, I'm going to demonstrate how electrolytic capacitors function is affected by temperature on this GE refrigerator here that had a failing motherboard due to electrolytic capacitor failure, and how cooling them down and heating them up drastically affects their performance in this motherboard's power supply. Then I'm going to show you on the bench how heating up a failing electrolytic capacitor drastically decreases its ESR, or equivalent series resistance, making it able to supply current to this light bulb. Likewise, I'm going to show you how cooling it back down will drastically increase its equivalent series resistance, rendering it unable to supply current to this light bulb. Okay, notice how this is still clicking. The reason it's clicking is because the capacitors, the electrolyte and the capacitors, of which they rely on for their conductivity and their low equivalent series resistance, is dried up. And the colder electrolyte is, the less fluid it is, and the less it conducts. So if I heat this up, I'll illustrate how the capacitors will start functioning again, albeit temporarily, because the electrolyte becomes effectively more fluid and less viscous. So I'm going to go ahead and heat this up with a hairdryer, and you'll see this will stop clicking. Okay, as you can see, the clicking has stopped, and now this 12-volt line will have started working. Now the compressor has started up, and the display has started working. It's warm in the refrigerator because it hasn't been working, but now the display is working as it should. I can hear the compressor running. Now, contrary to that, let's go ahead and cool these capacitors down. And watch as the electrolyte becomes more viscous and less conductive. I'm going to use this freeze it spray here on these capacitors. These are the ones that I suspect are bad right here, by the way. These right here. Okay, I've gone ahead and cooled them down. And as you can see, we're back to where we were before. So that illustrates the effect of temperature on electrolytic capacitor failure. Okay, I've got the bad capacitors out of the board here. And I'm going to do an out-of-circuit ESR test. This is one of the capacitors. Okay, it's saying an in-circuit leaky capacitor with an ESR of greater than 40 ohms. That's horrible. Should be less than 0.5 ohms, I would say, 0.5 or less. This is the other capacitor. It's saying open circuit or low capacitance. So basically this one is an open circuit. So these are definitely bad. Now this is a measurement of a good 470 microfarad capacitor. These are low ESR capacitors for power supplies, so this should give us a good reading. So it's reading 470.5 microfarad. This is a really good meter. I love this. And it's giving us a 0.41 ohm ESR, which means it's going to filter that AC out real well and provide a good strong current sourcing capability for that 12-volt line. Okay, so this is one of the capacitors from that motherboard, and this is a 470 microfarad capacitor. I'm going to do a bench test here. It is in series with a light bulb. I'm going to show how heating up will cause the ESR to drop enough to light the light bulb and actually give us a display here. This represents the voltage across the bulb right here. And I've got this signal generator set for 10 kilohertz, which is more than enough to make a 470 microfarad capacitor look like a closed circuit under normal conditions. So let's go ahead and zoom in here. So I'm going to go ahead and heat this up here with a hair dryer, and we'll see the light bulb light and the voltage across the bulb increase as the electrolyte becomes more fluid and more conductive. Okay, so the bulb is now lit, and you can see this is the voltage across the bulb, which is Not enough voltage, not a lot, but enough to light this bulb. This is I believe this is a 4-volt bulb. So the capacitor is very warm right now, and I did speed that up because it was taking a long time to heat the capacitor up enough to make it conductive. Now I'm going to go ahead and cool it down with this freeze it spray here, and watch how the conductivity completely drops off as the capacitor cools. So you see the bulb is getting dimmer, and our voltage has completely dropped off there. So there is no conductivity at this point. The capacitor is just completely looks like an open circuit, and the bulb has got no current flowing through it as a result of cooling it down. So electrolytic capacitors, their electrolyte will function better and conduct much better when relatively warm. But that's not to say that heat is good for, of course, for electrolytic capacitors. That is actually what accelerates their demise, is being hotter of an environment that they are in, the more quickly their electrolyte will evaporate and the capacitor's life shortened. However, once the capacitor is compromised, while they are operating, they tend to run hot because of their relatively high equivalent series resistance causes them to dissipate heat. And in doing that, they heat up and they tend to function better when they are warm than when they are cold, which is why when you have electrolytic capacitors on a circuit board that are starting to fail, you unplug that circuit board for a while, the electrolytic capacitor cools down, it will actually not conduct as well as when it was warm. And that's when you would hear, such as in the beginning of this video, where that control board was clicking. That was what was happening when the refrigerator was first plugged in. And when the capacitor did warm up, it actually did start functioning to some extent. So that's it for this video. I hope you found it interesting and informative. If you did, please give it a thumbs up and subscribe to this channel for more like videos. For more resources on equivalent series resistance and capacitor failure, go to techcircuit.org. Click on the website, go to the search bar, type in ESR. That'll take you to an ESR cheat sheet. Click on that, and these are typical ESR values for certain size capacitors and their voltages. Go back to the search bar, type in capacitor failure, and this will take you to a blog that goes into great detail about capacitor failure, how it affects circuits. It shows a properly functioning circuit simulation, as well as one with a failed capacitor, high ESR, how that affects the circuit. It goes into detail of how capacitors are constructed and how those ESR failures affect them.